Hello, everybody. Welcome to class today. Today, we're going to be talking about Module 9, which is the Hour of Code. And I'm a little bit partial to that one since the majority of what I teach here at Cleveland Community College is about programming and code. So I think this one is a lot of fun. You might not agree, but it is what it is, right? Hopefully you have a good time working through the lab for this module. I think it's a lot of fun. I think it's interesting and different and pretty cool. So, hopefully you enjoy it. Takes a little bit of a different look at programming and coding than you might otherwise normally see. But before we get into that, what I'd like to do is I would like to just do a few announcements here really quickly. The big one, the first one, would be that we only have about a week and a half or so left in the course. Next Thursday, which will be 1 week from this Thursday, July 29th, is the final day of this course. So you've almost made it to the very end. Congratulations. We just need to keep our heads up as we run toward the finish line so that we can finish strong. Because of that, we're getting toward the end of the semester. A lot of things are coming together here at once. So we just want to make sure that we keep pushing to get done with this last week and a half or so we can enjoy our last roughly 2 or 3 weeks before fall classes start. So there is that. I should be getting caught up on grading over the next couple of days. Lots of stuff going on here in order to get ready for fall. So I should be getting caught up on grading really soon. Look for your grades for Module 8 and Module 9 by Wednesday of this week. With those two modules being shorter, it kind of crams everything together. I say 7 days. Within 7 days after the modules due, which we would still be within 7 days after the modules due, I get everything graded. It just takes a while, So look for everything by Wednesday of this current week. The final announcement I want to talk about is the announcement for next week's live stream. We got one more live stream next week, and it's going to be from Module 10. But Module 10 is a little bit different. And one of the most fun things about kind of doing Module 10 and a lot of the other modules that we talk about in class is that, people are curious. You're probably curious about some of the things that you've read about or some of the things that you've heard about on television or seen in the news or whatever. When it comes to technology and computers and this and that. So what I'd like to do is I'd like for next week's live stream to kind of be a question and answer stream. So if you have questions, if you're curious about something, if you want to know more about something, if you've heard about a new technology that you'd like to know a little bit more about, or if you are curious about something related to computers or technology or something like that you want to know more about, then I want your questions and I want to be able to answer them in next week's live stream. So probably on Wednesday of this week, I'm going to post an announcement to the Blackboard. That's going to be a form to help collect your questions. That way I have them all in one place. And then, next week's live stream will be all based on your questions and answers to those questions. And that will be the final live stream of the course because, we'll be done later on in that week, right? So thanks for hanging in with me. Thanks for working hard. Thanks for getting through the summer semester. I think that's all of my announcements that I have, and really that's enough, right? Of course, if you have any questions, send me, outside of what you want, what you'd want answered for next week's live stream. send me an email and I can answer your questions personally in that way. But today we're talking about Module 9, which is about code or programming. We can use these two words interchangeably. And this is a module that's kind of near and dear to me as the programming instructor here at Cleveland Community College. And so what I want to do today is I want to talk about code in a broad perspective. Right, I want to kind of demystify things a little bit, define a few terms for you that you might have heard before that you might not be aware of what it is or what it means. I want to try to demystify these things in really simple, really easy to understand terms. And I want to show you some code. So we'll actually do a little bit of programming today on the live stream, just so you can see some code. Because the hour of code assignment that you guys do is a lot of fun, and it takes programming and it simplifies it way, way down to make it really, really easy for people who've never written a line of code before in their lives to kind of get into. But I want to show you a more realistic example of how we would do this sort of programming. So we're going to take a problem, kind of like what you would see in that hour of code assignment, where you want to take something and move it around and actually write a little bit of code that's going to help us do that. But first, let's talk a little bit before we get into that. And let's start out by defining some terms for ourselves, right? So when we look at some of the definitions of programming or some of the definitions surrounding code, oftentimes these are really complex or big words that people are kind of scared of, right? There's a lot of mystique around a lot of these words. You can see some of these definitions that I have here for function and variable and algorithm, right? And these are I don't know what that means. That's a big word, 3-4 syllables. And, you've heard it in movies as people would just furiously type on a keyboard or whatever as they, try to get into the mainframe or whatever. So what I'd like to do is take a few moments to kind of demystify some of these terms here for you. And so the first thing I'd like to talk about is just code. What is code? Well, code is nothing more than instructions. And we'll talk a little bit more about these instructions in just a few minutes. Because essentially what we're doing when we're writing code is we are giving our computer instructions. Because as we'll talk about more in just a few minutes, our computers are dumb. Right? We're smart, our computers are dumb. One of the things that you might like to think is, well, the computer, it can do it all. It knows it all. It can do any math problem for me. I can go on there and I can look up any information that I want to look up. I can figure anything out with my computer. And while, to some degree that is true, you still have to tell it things that it should do. You still have to give it instructions. And so when we write code, what we're doing is we're writing instructions for our computer. So when we say something like we've written a line of code, well, what we've written there is a single instruction. And so that single instruction tells our computer one thing to do. Now, if we have a specific purpose that's going to require multiple steps that we need multiple lines of code for, we group those multiple lines of code or those instructions inside of something that we call a function. And a function is just a group of instructions with a specific purpose. Now, when we get into our code example in a little bit, you'll see a function in action. And we'll talk about the things that you need for a function. Right? So we're taking multiple lines of code and we're putting them into one little container type of thing so that we can group them together. And a variable is a container for data. This is the way that I like to explain variables to my programming students. I like to say that they're a container for data. You can think of a container in any sort of way. Like, if you've got a Tupperware container in your fridge with some food in it, or if you've got a shoebox lying around with some stuff in it, or like a jar, or, anything that you can put stuff in. That's the way that I like to think of variables when we're programming. Because essentially what I can do with a variable is I can take and I can create and establish this container, and I can give this container a name. I like to tell my programming students it's like taking a label and putting it on a shoebox. So like if you want to take your tax documents and you want to put it in this box so you can keep them safe for later, you might print out a label that says taxes and take your tax documents and put them in that box. But just because you've put that label on there and put that information in there, that doesn't mean that you can't use that box for a different purpose later on. You can take your tax documents out of there. You can peel that label off of there. You can put a new label on there and put more stuff in there. You can take stuff out and put stuff in, right? Like it's not a forever thing. And with that label on the box, you don't have to reference anything specific that's inside of the box. You just have to know the name of the box, right? So when we use variables in programming, we use them to hold data that could change. That way, when we reference that data later on, we don't have to reference it by the data that's inside of the variable. We can reference it by something that's easy to know, easy to remember, i.e. the label on the container or the name of that variable. Now, the word algorithm is a big word. It's a word that you probably hear a lot. This algorithm, that algorithm. People talk a lot about the YouTube algorithm, for example. That might be something that you might have heard before. And an algorithm could be mathematical. It could not be mathematical. Right? When we break an algorithm down to its just purest definition, an algorithm is the sequence of steps required to solve a problem. So one of the things I like to tell my programming students again is when we're approaching writing some code, one of the things that we need to do is we need to define our problem. What is the thing that we need to do that we want this program to solve? Now, sometimes the problem could be serious. Sometimes the problem could be silly. It's all based on, what your goals are for this particular problem, or for this particular program, rather. And so from there, we can develop our algorithm. We can take and break the problem down into the steps that it takes to solve that problem. And one of the ways that I like to think about this is I like to think about it like you are putting together furniture. Right? Let's say you go to IKEA, you buy a new table. It comes in that flat packed box, and you have to take it home and you have to put it together. Right? So if you're like most people, you take that quick start mentality. You just take those instructions, you throw them to the side, and start trying to put it together. But remember, our computers, they're not as smart as we are. They need these instructions. So our computers would take the instruction manual and make sure it reads it through. That way it gets from the beginning, where you just have all the pieces kind of laid out there, to the end where you have the assembled table. So when we're thinking about an algorithm, all we're really thinking about is the step-by-step process that it takes to complete a task or solve a problem. And when we're thinking about things programmatically, that's kind of the way that we have to think about things. We take a problem and we break it down into its parts. And then from there, we can use our code to solve those little parts and build them on one another and ultimately make a program that solves our problem using that algorithm. And for a definition that I don't have up here on the screen, one of the things that you might want to know is what computer science is. Because really, when you break it down to its essence, computer science is the science of algorithms, that involve a computer. Right? So it's computer involving algorithms, or the step-by-step instructions required for solving problems using a computer. That's essentially what computer science is. So we've taken these big words that you might have heard of, like algorithm, computer science, all this kind of stuff that seems complicated and far off, and we've taken them and we've just put them into simple terms. That's what we want to do. Right? We also have terms like event, which is a user action. And it doesn't always have to be a user action. Although I guess waiting is a user action. When you think about how you interact with the program, you're either going to click your mouse, or you're going to tap your phone screen, or you're going to wait a specific amount of time for something to happen, or you're going to type on your keyboard or press a button. All of these things are examples of events. So when I write a program, oftentimes what it's doing is it's waiting on one of these events to occur. It's waiting on you to push a button. It's waiting on you to type something on your keyboard. It's waiting on you to click your mouse or tap your screen before it starts something else, before it triggers some type of action. So it takes that event and it uses it as input or data entering a program. So when we're thinking about input, it's much more than just typing some words into a form or into like a Word document or whatever. Just the act of you mashing a button or clicking your mouse, that's also input. It's just a different type of input. An output is data that it gives you back, a response to you, or data leaving a program. Right? So these are all definitions that we have. And so as we're approaching these definitions, one of the things that we want to keep in mind as we kind of think about, well, what is programming and what are the limits or extents of programming, is that essentially everything you use, every website that you go to, every app that you use on your phone, every piece of software that you use on your computer, Netflix, Hulu, all of these applications there, they all had to be programmed. They all had to be developed by somebody or a team of somebodies. And these people sat down and they wrote code to create things. And that's one of the things that it wants you to look at in your lab, is that to get these things in the movies, like to get the CGI and all that kind of stuff working correctly in the movies, it required somebody to sit down and write some code to make it look right. And all that kind of fun stuff. So it's important to understand, the extent of all the code that is used, and it's also important to understand when and where code is used. Because in the modern world, every industry, every job, whether you're at a bank, you're at a hospital, you're at a manufacturing facility, you're with the police department, you work in business, whatever, every job in the world uses software nowadays of some type. They have websites of some type that they have to use. And all of these things have to be programmed. So maybe, if you're going through, like, say, a nursing program, and you get to a point where you say, you know what, nursing isn't for me. I don't really like nursing much anymore, but, I remember that module on coding from Mr. Ramsey's class. Maybe I can look more into that, and then I can still be a part of the healthcare field and just help write software for the healthcare field. That's a possibility. Right? You could come take some more programming classes, and we'll be glad to teach you how to program. Another thing is, I work in business, but now they're asking me for a website. If I can help make a website, how do I do that? Well, that's programming again. So you'll want to remember us here from that. One of the things that I like to say as we're kind of approaching this module, regardless of, when we're doing it, if you like the stuff that you see in the module, if you have fun with it, if you want to learn more, then we'd love to have you in some of our classes here in the programming, in the IT programming degree. Even if you want to just try a little bit more to see if you like it, we've got stuff there where you can get a little deeper into it. It's just something to think about, because it's also like when I show people numbers as to what you can make as a programmer. Those are pretty large numbers, and they get especially interested in it at that point. But you also want to make sure you like it, right? So if you're interested, if you think you want to know more, get in contact with me. I can help you out. But we also say that our computers are dumb. Because, you're smart, right? Like, we are smart as human beings. We can understand and we can comprehend, and we can also look at things in context, which is a big deal. Our computer doesn't do that. Our computer needs us to be specific in the instructions that we give it. And it will only do what we tell it to do. Now, one of the things that's interesting about a computer is the way that it interprets the data that we put in there. Right? So let's say you are writing something down. Let's say you're writing something down, right? You know what that letter is. That's the letter A. That's a lowercase letter A. Then there's also this letter. That's also the letter A. That's an uppercase letter A. So within our understanding, we can look at the two of these and we can say A, that's both the same letter. I understand that. I went to kindergarten. I know the difference between uppercase and lowercase a. Our computer doesn't. Our computer is not that smart. It sees these as two totally separate things. So if we were to type a word, apple, in lowercase, and then apple, starting with our uppercase, our computer sees that as two entirely separate things. So what happens here is this brings about the need for precision when we program. How important it is to program precisely. When we use uppercase letters and we use lowercase letters, to us they're the same. To our computer, they're very, very different. So we need to be sure that we're using uppercase letters and lowercase letters in the places that we want to be using them. Now, why does our computer interpret it that way? Because of the ASCII table. This ASCII table is how our computer interprets letters. So, for example, right, if I look at that lowercase a, it's here. It has the value of 97. So when our computer looks at a lowercase a, it sees the value 97. Well, actually, it doesn't see the value 97. It sees something a little bit differently, which we'll talk about in just a second. It sees something completely different than it does when it looks at our uppercase A, which is right here. That's a 65. So when it sees a lowercase a, it sees a 97. When it sees an uppercase a, it sees a 65. And it sees it even more different than that. It sees it in binary. Right? We talked about binary before. Binary is our sort of our computer breaking down data into zeros and ones, ons and offs. So for example, if we wanted to look at that lowercase a, let me just do a little bit of quick figuring here. If we look at that lowercase a and we translate that into binary, it would be 0, 1, 1, 0, 0, 0, 0, 1. So in binary, that's what that lowercase a is. For our uppercase a, however, it's going to be 0, 1, 0, 0, 0, 0, 0, 1. So just that one little bit different in there makes it a completely different character, which is pretty neat, pretty interesting to think about. So we want to be careful when we're programming. We want to make sure that we are writing the things that we need to write. We're being specific. So what I'd like to do is I'd like to show you a little programming example. And in order to do that, here I'm going to pull up a little development environment. And let me make this big here so you have an easier time seeing it. But this is some code here for a little website. And what I want to do is I want to take this circle and I want to make it move on this, in this area here, whenever I mash a button on my keyboard, up, down, left, or right. So right now, you can see in my circle there, and if I try to mash my buttons, I'll try to hit it hard so you can hear it. It doesn't do anything. So what I'd like to do is I'd like to make this circle move when I mash a button on my keyboard. And we can do that. So some of the things to point out here, this is an HTML document, which all of our website documents are built upon HTML documents. I have an HTML document here. I have a JavaScript document here, which is where we're going to put our code. And then I have a CSS document here that kind of makes our HTML look pretty. So we're going to focus on this script.js file here. But in my index.html, I have my circle. This is the code for my circle here on line 10. For some reason, my zoom isn't working, so let me try to fix that really quick. Let's see here. There we go. Right here on line 10, I have my circle. And you can see I've given it the ID of circ here. That's going to be important to us. So I'm going to click on that script.js file so I can start writing in that file. And what I want to do is I want to be able to identify that circle in my code. So I'm going to add a little code to do that. And I'm going to put this reference in a variable. So I'm going to write a variable container in JavaScript, which is what we're using here. We use the words var to create a variable. And then we can give it a name. We can apply some kind of label to this variable container. So something like CIR-CLE for circle. So now we have this box established with a label on it. And the label says circle. So whenever we need to reference the values that are in this box, later on, we can just reference it by the word circle. And so we can set that equal to Document dot query selector hashtag CIRC, because that's what we had it named in our other file. So now instead of writing out document.query selector CIRC, every single time we just have to write circle. Which is pretty good. What we'll also do here is we'll create an X and a Y variable. Since we're going to be wanting it to move around, we're going to want it to move around on like a plane, X and Y. Right? You know, remember back to like algebra or geometry class, you looked at things on the x-axis and the y-axis. That's what we're going to be doing here as well. So we're going to create a variable x, and we're going to set that equal to 50. And we're going to create a variable y. And we'll set that equal to 50 as well. Now, I accidentally hit my caps lock key there. And you can see that that color there, when I wrote VAR, is different than on the line above it. That's because it's uppercase instead of lowercase. And now my computer doesn't have the first idea of what I'm talking about. So precision is important. VARY also equals 50. Now, one of the things that you might notice that I'm doing here is I'm putting a semicolon at the end of each of my lines. And this semicolon kind of works the same way as like a period in a sentence in English. This tells my computer that this instruction is finished, and what's on the next line is the new instruction. So now what I'm going to do is I'm going to create an event listener. We talked about an event. An event is a user action. And so with that user action, we're waiting on the user to do something in order to see something happen on our screen, right? So we're going to create an event listener, document dot add event listener. And we're going to listen for a key down event. And when we get that key down event, we're going to run our move circle function. Now, we don't have a move circle function yet. We've not created that function yet. Remember, we said a function is a series of instructions for a specific purpose, all grouped together. So what we're doing here is we're saying we're going to use a function called move circle. We're going to run that function whenever a key down happens, whenever somebody presses a key on their keyboard. Right, so we should probably write that move circle function if we're going to use it for something. So when we do that, we start out with our word function. That specifies that this is a function. And then we're going to start coding, and we're going to write our move circle name. So that's going to reference back to what we're supposed to do in our event listener here. Now, there are two things that a function needs in order to be a function. One of them is to have a set of parentheses right beside the name. And this is where our function takes what we call arguments or parameters. These are specific values that work inside of our function. And here we're going to use one called E. So it's kind of like a variable. It's kind of like a little container where we can put a label on it and use it later on. It's just specific to this function. Another thing that we need to be able to define our function is a set of curly braces. Which, if you hold down your shift key and, you use those keys that are close to your enter key, they're on the right-hand side of the keyboard. They have that little squiggle in them. You might call them curly braces or curly brackets or curly cues. You might have heard of some name for them. We put them with our function here. And we use them to define where our function begins and where our function ends. So we wrap them in these curly braces. That way, since we said that, a function is a group of instructions that have a purpose that work together, this groups our functions together. So we have them all in this function group. And so now I'm going to write a conditional. And I'm going to say if e.code equals arrow up. In quotes like that. And so that's specifying my up arrow. I'm going to add some curly braces there. Since our up and down is on the y-axis, I'm going to manipulate the y. When I move up, I'm moving in the negative direction. When I'm moving down, I'm moving in the positive direction. So I'm going to say y plus equals 50. And it'll move it down. Or actually, I'm going to say minus equals 50 because we said we're moving in the negative direction here. Y minus equals 50, so it'll move it up 50 pixels every time our up key is pressed. And then we will just C dot style, or actually that's color dot style dot top equals tick marks $, curly braces, y px. So that's what we write there to get it to move, right? So we're setting the x and y here. And so now if we have this saved and we run this again, we can see our circle starts in the same place, but if we press up, oops, we made a mistake. Oh, yep, see, I put color here instead of circle. That's supposed to be circle. .style.top. You have to be precise. Now when I hit up, it moves up. And it keeps on moving up until it's off the screen. So we're going to want to do more with that, right? We want it to move down as well. Since we want it to move down, I can just take this, copy it, because we're going to let our past successes enhance our future successes. And I'm going to paste that in here. And so this is going to be now else if, and arrow up is going to be changed to arrow down. And when we're moving down, we're moving on the positive direction. So I can change that to plus equals 50. And this last line can stay the same. So now when I run that, if I go up, or if I press up, the circle goes up. And I press down and the circle goes down. So now you can see it going up and down on the screen here. And we can do the same thing for right and left. In fact, what I'm going to do here is I'm going to take both of these and I'm going to copy them, just in the interest of time, and paste them in here. I'm going to add my word else in front of this. This is going to be arrow right. Or actually, it's in the minus direction, so this will be arrow left. This will be arrow right. So now we're going left and right. So we are on our x-axis instead of our y-axis. So going to the left, we're going in the negative direction, our x-axis. So we can just change that to an x. And change that to an X there. And change that to an X. And that to an X there. And so now we have a program where we can go up, down, right, and left. Oh, you know what? I also forgot here. We still have top here. That's breaking as well. I need to make that left instead of top because we're on the x-axis. So now I can go left and right and up and down. So now I'm just mashing the keys on my keyboard, my arrow keys, to get this to go up and down and left and right, which is similar to something that you do in your lab. You just use a lot easier code to get to this point. So let me zoom back in on this code again so you can see it again. This is our function that we wrote to help move our circle when we press an arrow. So what it's doing is it's listening for that event. And when that event happens, it runs this function. And then it checks to see which key you pressed. So even if I press something like P on my keyboard, that function is triggering. But it's also checking to see which key I pressed. And if the key isn't in one of these descriptors, it's not running the code. So if it's not up, arrow down, arrow left, or arrow right, it's not running that code. Now, one of the things that I like to do that people really like is to see the color of things change, which is kind of what the, where that whole color thing came in earlier, where we got a little bit confused. Because people like color, and I like to do color here. So one of the things that I like to do is I like to add a little bit of code to this that will change the color of my circle to something random every time. So in order to do that, I'm going to create myself another variable here. I'm going to call it var random for random number. And it's going to get me a random number. So I'm going to set that equal to math, capital M math dot floor, parentheses math dot random times 360. So we can talk about the way this works right quick, and it's pretty interesting. Right, because in JavaScript, which is what we're using here, math.random gives me a number from 0 to 1. So it could be like 0.2, could be like 0.5, could be like 0.0798364, whatever, right? So I get this random number here, and I multiply it by 360. So that could be any number between 0 times 360, which is 0, and 1 times 360, which is 1. Now, it also could have some decimal places after it, so that's why I use this math.floor here. So it rounds it down to the closest whole number, wherever it's at. So if it's like 7.465, it rounds down to 7. If it's 8.985, it still rounds down to that whole number. It would be 8 in that case. So now I have this random number. And so what I want to do is I want to generate it every time. So I'm going to start out with a random number, but I also want to generate it every time I run one of these button presses. So I'm going to take and copy this, and I'm going to put it into each of these conditional statements or if statements that are in my function. That way it'll get a new random number every time one of these things happen. Let me copy that again. And I also want to add the code to change the color. So we'll add that to the bottom of each of these conditions here. We'll say circle dot style dot background color equals HSL random comma 50% comma 50%. So this will give me a random color within a certain color value every time I press a button. So we can take this and copy it and put it into each of these as well. And so now, when I run this, each time I mash a key, you can see it changing color. So notice that it always starts in the same place, and it always starts as the same color. And because that was what we dictated in other parts of our code. But whenever I hit one of my arrow keys, it moves my circle, and it changes the color of the circle. So just like, you know, when you're doing your labs and you're moving around BB-8 or whatever with the Star Wars situation, this is more or less the same way that works. Right, so this just gives you sort of a more realistic view of code and how code works. That's a little bit more in-depth than what is inside of your lab, right? You know, the lab kind of takes it from a very high overview point, and we got a little more in-depth here just so you can see a little more of what's going on behind the scenes when this code is running. And with that being said, that's all that I have for you for today. Remember, we're running up to the end of our class. Remember, next week's live stream is going to be a question and answer live stream. So it's all going to be based on you all. Your assignments for Module 9 are due tomorrow by 11:59 p.m. So make sure you get all that completed by then. I'm going to hang out in the chat for just a minute, just in case anybody who is watching live with me has any questions. But that's all that I have for you for today. Thank you for watching, and we'll see you next time.